What is the EDGE Army? The Army is made of some pretty spectacular people, 25 men and ladies between the ages of 20 and 65. These individuals represent so much in the industry that Eric and I of EDGE are so grateful for each one of them, representing with integrity, skill, character, drive, kindness, motivation, encouragement, achievement, determination, talent, silliness, exceptional, significant, extraordinary, accomplished, and brilliant. What they are doing for others in this industry is a legacy and one that you should know more about. Truly honored to know each of them. They are family. Take a moment to get to know all the people part of EDGE Army. Together, all these members have over 250 years of welding experience, with the expertise going in fields such as performance automotive, fabrication, military, production manufacturing, general repair, prototypes, landscaping equipment repair, residential repairs, industrial conveyors, robot sculptures, welding art, agricultural repairs, custom tool and die, mold building, aerospace, Department of Defense, race car fabrication, power bar weld, custom work, biopharmaceuticals, structural, construction, towers, educators, journeyman steam fitters, energy and power industry, aerospace prototyping and code work, new welding machine design, programming, prototyping and repair, tech support, millwright, production, bicycles, oil field support, music industry, chemical plant, power plants, nuclear plants, industrial laundry, sanitary, brewing, cryogenic refrigeration industry, and heavy construction equipment. Please note that I did record this video with the microphone placed about 1 foot away from the speaker, so if there's any feedback, any interference, I do apologize. The last 10 minutes of this Q&A panel, my microphone did get a lot of interference from having my microphone so close to a speaker. If there are any questions that we did miss, please put them in the comments below and we will love to get back to you.
You gotta speak up into it.
Hello.
There you go.
All right. Can you guys hear me?
Yes.
All right. Go. Let's stand over here. All right. Hello and welcome to the EDGE Army Q&A panel. If you're in the area, we'd love to have you stop by and ask some of the Army some questions. All right. Can one of you guys start introducing yourselves and how long you've been part of the EDGE Army?
Oh my God, it's not hot potato.
I've never spoken to a microphone before.
Hello, I am Ryan, 810 Middleworks, and I've been in the EDGE Army for about a year.
My name is Johnny Jones. I've been part of the EDGE Army for about 3 years now.
Hello everyone, I'm Johnny Snyder from Johnny S. Weld, and I've been part of the EDGE Army for about 4 years now and loving it. Hi, I'm Tyler Caton. I've been with EDGE Army for about 4 years now.
Hey, I'm Lisa Watson, and I'm an EDGE Army member for like a year. I'm Danae Bushcutter, and I've been an EDGE Army member for 3 years.
Hi, I'm Brian Legalio. I've been in the EDGE Army for about a year now.
Bryn Otto for 1 year.
I'm Jerry Lynn Quiava, and I've been in the EDGE Army for about 6 years now.
I'm Austin Hill, and I've been in the EDGE Army for about 5 years now.
I'm Harrison Stone, been with the EDGE Army for about 2 years now.
And I'm Tim Thede, and I've been in the EDGE Army for 1 year.
Awesome. All right. Thanks, guys. All right. Is there anybody here live that wants to ask a question?
Anybody got any questions for us?
Come on over if you have any questions. Come on over.
So guys, so what is the dirtiest rotten stuff that you guys have welded with the cuts?
Who's got a dirty rotten weld?
A fryer at Sonic.
Welded like a carpet cleaner one time. That thing was pretty bad. The smell was awful. It smells like, piss getting burnt. That's what it smelled like off those carpets. It was pretty bad.
I had to fix a crack in an oil pan, and that absolutely sucked.
All right, so I was at an orange juice plant. It took me a long time to drink orange juice after being there. Yeah, that's all I'm going to say about that.
I did a repair on a transmission once that had been sitting outside since like the 50s. It didn't work.
Way easier than everybody else's. I just had to weld galvanized. That's way easier than everybody else's answer.
I had to weld a intercooler and had to strip all the powder coat from it, which was kind of difficult, and it just kept exploding all over the lens inside the cup.
All right, so you've welded galvanized with the cups. Have you ever had any issue with spatter coming back at your cups?
So I've also done the galvanized with it, a few like bolt heads and stuff like that. If I didn't clean it, it definitely explodes and comes back into the cup a little bit, and you'll have to clean it out. But it's kind of hard to avoid.
Do you have a specific size cup that controls any of that spatter coming back towards the cup?
Typically, for anything generalized like that, I'll use like a 10 or 12. It's a little difficult to avoid just because you're heating that up, and that surface, that coating just wants to come back no matter what. It's kind of hard to avoid. It's not hard to clean up. Or what I'll do is I'll stick my tungsten out a little bit further to keep that from splashing back onto the cup.
Thank you.
I mean, basically same answer as him. As far as what cup I would use, basically the same 10 or 12. Mine was always on like a positioning table, so I needed the gas to kind of trail a little bit. So I always try to use a bigger cup, but the spatter, can't really avoid it.
So when you go to do that next time, if you have the ability to soak them like 24 hours in vinegar, they'll be raw material at that point. It'll remove the coating. But if you do weld on that coating, it's in an off gas, and that's where you're going to start having problems, regardless of the size of cup that you end up.
So which one of you is the best welder here?
Which process? Yeah.
All of them.
And that's when I leave. Not me.
I'd say, like, theory-wise, it'd be between one of the instructors. Like, Brian knows a lot, for theory. I think Austin and Johnny Jones is pretty close when it comes to, like, TIG. I mean, they're both slick. And Tyler, too. It'd be close.
Yeah.
I'm still trying to figure out how to turn on the machine.
All right, so we'll start with some of them that people commented on on the post. So this is a good one. What is your favorite welding machine and why? And be careful with this where we're sitting.
That's good. Give me that.
Consider where we're sitting when we answer.
So lately, I've been using my new Typhoon 330, which is right there. And I can tell because I have 10 years of experience in TIG welding. And I used to use like really expensive German brands and American brands and stuff like that. I can tell that machine, especially for the price, is in the same level as high-end machines like EWM or Fronius. The same. It's amazing, and it's really affordable, and it's super advanced. So if you have any questions, I can show you that thing.
So I also have a Typhoon 330 that I use every single day, and I work in a job shop, so we deal with multiple types of material thicknesses, and we pretty much take any job on that we have the capacity to do. So we have to be flexible. I've used HTPs, I've used Millers, Lincolns, and so far that thing has given me a lot of capability, especially in aluminum since it's so finicky. I like to be able to play around and like get sciencey with like my waveforms and stuff like that, and just see how that kind of affects the finished weld appearance.
Okay, we'll move on to the next question, unless there's somebody here that has a question. Okay, this gentleman here.
My name's Cody. Some of y'all know me. My question is, I'm a newbie in TIG and trying to expand my palette of what I can do. Being a new person, what's the best way to know what size cup you need, what you're gonna stick out, how much farther you can have stick out by the advantage of the cup size, and things like that. Basically just the down and dirty beginning, steps of that. How would you approach that, coming to the products?
So me being a welding instructor, I have this question asked on the regular. A good general size that I always go with is like a 10 or a 12. You can cover about any material with that. Obviously, if you're doing higher end stuff, that might be different, but that's a pretty good general purpose one. For stick out, I always tell my students the diameter of the cup is about how far you can get away with sticking it out without having any issue. So that's what I recommend.
To add on that, the diameter of the cup, when they refer to 10, 26, that's a measurement in sixteenths of an inch. So that's relevant to your stick out at that point. When we're talking about aluminum or alloys, aluminum, I would prefer a smaller diameter cup. I like to keep my gas envelope and keep my etching stone minimum. And you can manipulate the size of your bead profile by your gas cup. So like compared to like a 5 or a 6, your bead will be a little bit wider on aluminum per se. When you get to carbon steel alloys like stainless and higher end like titanium, monolink now, you want a bigger envelope of gas coverage. And then when you get more like into higher grades, you're gonna want a bigger, and then you're gonna want to go like 10's a great cup that does a lot of things. You can do most things, and then when you start getting into like our world titanium, and you guys do some right, you want to be in what 23, 21. Yeah. Yeah.
So, so you were saying the titaniums. I'm starting to mess with a lot of bronze. Would you follow the same thought process in that?
So like, are you take brazing bronze? So what I actually found with TIG brazing bronze, I like the big cup. Like a 10 would work, be great. But I also like doing like one pulse a second, and it kept the bead very clean instead of getting that like that hazy darkness color in it. Anyone else want to share on that one?
I would also say a 10.
The pulse, does that eliminate your burn way on the bronze? You know, you hit bronze here and it's hot over here.
Yeah. The pulsing does eliminate your haze zone and the runaway. But what I found more importantly was like if you get like 5 dabs into your bead, you start getting like this black like sootiness, right? And when I
Yeah, you'll get that when you're doing TIG brazing. It's because you're heating the base metal up too much. Because the difference between brazing and welding is you're not, melting your base metal down to create that pool. So typically when you're seeing that, like I said with the pulse, is that's going to help you kind of just get that immediate heat you need just to melt the wire onto the joint.
You said you're doing 1 second.
Well, that's going to depend on you.
Yeah.
So typically when I do a lot of sheet metal work, so I use pulse all the time for everything. Except for aluminum, I typically don't use pulse unless there's a bad fit up and a gap, and then I'll use that to fill the gap. But 1 second's usually pretty good, but that's going to I base it off like my travel speed and how fast I want to move across that joint, and then your background amps, and then your cycle is where you can play around a lot. So sometimes I'll set my amperage really high, and I might go 25% on my cycle for that max amperage for that. So say it's 1 second, and then 1 second, only 25% of that full cycle, 0.25 seconds, is going to be at that max amperage. And I'll set my background amps, depending on what machine you have, I can set mine down to 3 if I want to. So a lot of people will say, oh, it's like packing, but if you set the amperage high enough, you're still getting enough to get a good amount of penetration into that joint where it's a quick flash. And if I'm doing like outside corners or anything like that, I'll literally just lay wire and I'll just run over the wire, and you still have a really good joint on sheet metal.
All right. So the next question on the list, if there's anybody here that wants to ask one, what tungsten do you use?
CK laser.
2% lanthanated blue tungstens are like perfect all around tungsten. Laser works really well too.
I'm partial to the 2% thoriated for my line of work and what I do most of the time, but for personal stuff, I do like the rare earth, the laser.
I'm with this man over here, Austin. Yeah, 2% lanthanated for everything. Aluminum,
stainless, titanium, Inconel, everything.
I also typically use the CK laser. If I'm not using that, I typically go for 2% thoriated.
E3. Just kidding. I don't use that stuff.
Do any of you use anything different than what's been said? All right.
CK laser seems to be pretty typical.
All right, cool.
There's that.
All right, the next question is, what is your favorite part of Fabtech?
Getting to meet everybody. It's not so much like the show that brings me back every year. It's the events after and being able to meet and talk to new people and network.
I think seeing there's a ton of people that are always here, and you get to meet a lot of people. That's really cool. But every booth evolves every year, and every new product that's always on show is, I think, one of the coolest parts.
Basically, getting to meet everybody and make that relationship that you didn't have on the internet was really cool for me. Also, Hard Rock, that was a blast. They EDGE Welding and a lot of other sponsors. They had a great time. I would definitely go back again. It was awesome.
For me, it's been meeting and connecting with other women in the trades has been really, really fulfilling. And everybody just seems to be on the same page. We're all very like-minded and have similar hobbies and personalities. So made a lot of friends here.
Ditto to what everyone has just said. Me attending my first Fabtech, I was a nobody, and just being here and like everyone said, meeting people. It's opened a lot of doors, and I've been able to work with some amazing organizations and companies just by attending Fabtech.
Well, for me personally, because I moved from another country, I finally can meet people who I used to talk on Instagram for like 5, 7, 8 years, and now I can see you guys personally, and that's actually an amazing opportunity, and hopefully many people can do it too.
Pretty much with all they said, one of the things I really like is that we can all kind of get together and hang out and spend actual time together. And then the best thing I find, since we all work in different fields, some similar, I get to pick people's brain in the industry in person and just kind of expand my like toolbox of knowledge, and then I can apply that to things I do, and that just kind of grows you as a welder.
Get a nerd out with like-minded people. Like, and conversations, like actually conversations in depth about welding don't happen very often in my neck of the woods. So, you know, unless I call someone and we sit on the phone for 2 hours and we just start nerding out on welding. Now, this is just the land of talking about it and living it. Rare environment here.
It's like a mini family reunion with the Edge Army every year. It's always a good time.
I pretty much was going to say the same thing.
Thanks, guys.
I got one more. The amount of knowledge that you can get in a 3-day period is so much. That's the best.
Yeah, that's awesome. Anyone else have anything else to add to that? All right, we've got Daniel here. He has a question for you guys.
Hey, I got a question. I've been welding for 35 plus years, and I'm not afraid to admit that I'm learning every day. My question is does you all have a specific angle of tungsten grinding point that you all like to use? Anything in particular? I mean, or do you all have for different purposes?
So it kind of depends what I'm doing. If you have a little bit less of like a steep angle where it's more of like a dull point, you actually get more penetration. The sharper the point, you get less penetration. So if I'm doing really thin sheet metal, I might go like 15 degrees, and it's going to really help with keeping that from wanting to punch through.
Right.
So angle does matter outside of just like a preference. It depends what kind of job I'm doing.
Right. Okay.
So like once I maybe get up to like 1/4 inch, I'll go a little bit duller and just kind of help with that.
When I do carbon or DC welding, carbon steel, stainless steel, I elongate the point to a fine point. When I'm doing stainless or aluminum, I narrow the point down to have a broader point so it can handle the amperage a little bit better. I even when I do pipe or if I'm doing sheet metal, I like a very sharp point. So it's point and shoot. Where I point that tungsten, it's an establish a puddle.
Right.
Especially when like walking the cup, like as I'm swaying the TIG torch over, point and shoot. And as your tungsten degrades, it's less defined, and having that elongation really helps it last a little bit longer.
Whatever my bench grinder will get me to, that's plenty fine with me, to be honest with you. I mean, I'm not doing any of the aerospace or anything like that. If it holds, it holds. I'm just going for that.
So you got your people that grind on a wheel.
Yeah, I've done a grinder one time.
A grinding tool, you know.
Till they buy me one of them, I mean, it's just what I get's what I get.
All right. Anyone else want to add to that? All right. Next question. What is your prep procedure for aluminum versus mild steel or stainless?
Brush is pretty good with aluminum, if depending on how dirty it is and the oxidation and all that. But I mean, sometimes I'll run the TIG torch over it, do a little pre-clean, and then go back to the start where I'm starting to puddle at, and that does a good bit.
Mostly, other than actual mild steel, other than like cleaning that with an actual grinder, if it's stainless or aluminum, I usually just prep it with Scotch-Brite and then acetone. I found that to be the cleanest way to do everything.
All of those I use as well. And I have recently become a big fan of acid etching for aluminum. I've seen a world of difference in that, in the prep and the way that it welds. It's way better quality.
What all of them have said, acetone, Scotch-Brite, stuff like that. One thing I teach my students to do when they're prepping joints, like especially on aluminum, like put another piece or a straight edge right next to that and clean it so you've got a nice crisp line of where you clean. Makes a world of difference. And it looks cool and better.
Well, basically same for me. Acetone, Scotch-Brite, file. I like to use file. And if it's a mild steel and it has that, I don't know what's the word for it. Huh? Yeah, mill scale. It has to be cleaned till it's like actually shiny. So yeah, that's very important for that material. But for other ones, I don't know, Scotch-Brite, acetone. That's it.
So I'll do a little bit of self shout out. I've worked with weld.com, so I actually did a whole video on welding with 30 materials and kind of went over like, here's how it welds when you weld 30 and here's how it welds when you weld clean, just to show like the contrast. So like same thing they said with aluminum. I've actually never tried that acid etching, and I'm going to pick your brain about that later. But typically wire brush inside of like outside like open corners. And if I'm going on anything where I'm going to go inside with it, I'll use like a straight edge or something to just keep it from looking messy outside of like a finished product. And typically acetone. And depending what I'm doing, like if something needs to be fully stripped of mill scale for carbon, let's say we're going to get it powdered and we're not going to blast it, I might dip it in like acid and completely strip it and prep it that way. So it really depends, but that's kind of what I stick to.
Wire wheel and a spool gun.
Right. Anyone?
I work at a tool and die shop and mold makers, so I'm pretty spoiled. Most of the surfaces I weld on are milled surfaces, so I don't have to do too much.
Okay. Anyone else have anything to add to that?
I do have something else too, just based on my experience in my shop. So we cut everything on a laser, and you can cut with nitrogen or you can just cut with shop air, depending on what you're doing, and it changes like speed and rate it will cut. So we did a run of these parts that we cut carbon steel with shop air. The first part I welded because it impregnated the joint, because that edge is where it's fitting up. Tons of porosity. So every single part I had to go through and clean every single edge, and it took a ton of time just from not cutting it with gas.
All right. Anything else from anyone? Okay. All right, anyone here have any questions? Over here.
This is gonna be good.
Okay, so what do you guys think the biggest advantages and disadvantages are for the edge cups when you're running the edge welding cups?
A little bit louder. Can't hear you. Put the mic in your mouth.
Okay, so what do you guys think are the biggest advantages and disadvantages out of using the edge welding cups?
When you drop them.
I'll give you a perspective of disadvantage from educator point of view. The gas envelope is so broad that it compensates for a lot of lack of technique because the gas envelope's so good. But in the value of them in a student's hand dropping is a little rough. But other than that, the advantage is how stable the gas envelope is on like dynamic corners, like something that has a couple edges. It's pretty impressive. That's all I got to say about that.
I'm pretty rough on like all my tools, so my heart gets broke every time my cup does. It hurts.
Personally, I like the visibility that they provide because I weld in a lot of really tight, complicated, hard to get to areas, and any amount of added visibility is a huge bonus. Being able to see behind your cup, very, very special.
I think some disadvantages are they are really nice cups, and everyone likes the look of them, and everyone wants to be a cool Instagram welder with colors, and everyone just says you need a big cup for that. But a lot of people don't learn the basics on smaller things before they just jump into adding a bunch of gas and cool colors. So I think I would say that's really one of the only downfalls. I think you need to learn a little bit before you start just jumping into things you don't know about. But advantages, I mean, they're the best cups out there. It's you can say you have cool cups. That's one, and I mean I weld a ton of titanium, and there's huge cups for me. There's small cups for. I mean the custom availability of these cups is just tenfold above everyone else. I think.
I'm gonna add to that. Every time somebody comes in my shop, I'm like, yeah, I want to show them something cool. I go over to that box and I open that thing up. They're like, whoa. I'm like, yeah, that's what you're paying for right there, buddy. That's what you're paying for.
Kind of what Brian was saying about the education standpoint. When it comes to demoing for students, TIG is probably one of the hardest process to actually show a group of students because the arc and all that is so small. So having a clear cup, I can at least have students around me, especially if I have any sort of travel angle or work angle. It'd probably be an advantage.
So I weld a lot of titanium. Like it's my 90% of the stuff that I do, it's titanium, and it requires a lot of coverage. And edge cups, they actually help me to save argon. Really, I use much less, and I get perfect coverage. And the welds are always silver, the way they have to be, and I'm super happy with that. But if you break it, you break it. So don't drop it like anything else.
Biggest thing is the variety and the customization that you guys can do. It's amazing. Pretty much a cup for every application you can think of.
I mean, basically what everybody else said, except the breaking it part. I broke Austin's 2 weeks into working with them, so I quickly learned how fragile they can be sometimes. So you got to take it easy.
Pretty much what everybody else said. Sorry. Advantages is visibility. I have actually really pushed the stick out on the tungsten as far as the gas flow. To get into the hard to reach places. Disadvantages, I am very clumsy, and so I will break the block. It's my fault though, not the cups.
So advantages, kind of like what they said. The reason why I like the glass is if you're in tight spots, like I do some similar stuff, Jerry does, you can see through it. And what I really like about it, since it's clear, your arc, the light from it doesn't get trapped like it would inside of like a normal cup. It kind of expels out and it lights it up like a flashlight, so you can see the entire area. And just like, especially with the type of work that I do, where it's a lot of different materials, different thicknesses. Having like a variety of cups I can use and have that at my disposal to be able to do what I need to do makes a massive difference. And especially like typically do aluminum, you just use like normal, like maybe some number 5 calified or something like that, and you don't really have like a very like stable gas flow, and it causes fluttering and your arc to kind of jump around that area. So being able to get like a quartz cup and be able to weld AC, or if I need to weld like, we have 300 amp welders and we're doing something really thick, to be able to have a quartz glass cup they can still really see, and it's going to be able to take that kind of abuse is a massive advantage when you're welding.
All right. Good answers, guys. Awesome. All right. The next question that somebody commented about is, how do you know if you have a pre-flow or post-flow problem?
A good indicator of a post-flow problem is tungsten color. If your tungsten is not silver, if it starts oxidizing from the transition of the inert atmosphere leaving, you need to bump up that post-flow a little bit. Pre-flow, I typically put like a half second. I don't want to hit that pedal and wait for it to start. So, but you need to get that gas flowing prior.
I would say probably the only pre-flow problem is if you'd notice it a lot more on aluminum whenever you need the etching, but whenever you go to start the arc, you would get a little bit of dirt in your puddle.
Sounds good? All right.
So what's been the most rewarding part of your career so far?
Repeat that one more time. I didn't hear it.
So what's the most rewarding part of your career so far?
I mean, this is a pretty big step right here, being here. I don't know much, to be honest with you. I know a little bit, but I mean, I'm just be sitting with these guys that have all this experience. This is pretty cool. I mean, I've taught this guy everything he knows. He helped me weld titanium the other day, so I'm learning a lot. But this is definitely the most rewarding.
I think the most rewarding part is, mostly you see it here, but even just people messaging you on social media and just telling you that either you inspired them to do something or that you helped them learn something.
Yeah, what Austin said for sure. It's really nice being able to connect with other welders and fabricators and just being able to answer their questions and help them, because it was such a struggle to learn, and we're always learning. We're still learning, but it's nice being able to help other people for once.
What they said. I mean, being an educator, all of us help people, probably people we don't even know that are watching, but being an educator, I get to see firsthand, when I've got a student calling me, oh, I finished this job, I'm headed to a next, and just, doing awesome things and making way more money than I do.
Well, I would say it's the community, of course, because amazing people and the ability to help, and also people help you too, because I don't know, I think welders are pretty friendly, and it opens so many doors inside the industry, and sometimes you get crazy surprise you would not even expect to get. So, say from my experience.
Kind of similar to them, just being able to reach out on people's social media. They come to you with questions, and you kind of just help them build their skill set and what they can learn. And from my personal experience, I have some buddies that I play with online that are younger, and they're just getting into their 20s now. Both of them decided to go to welding school because of just them seeing my work and what I do, and me explaining my experience. Because if I wasn't doing this, I don't know what kind of career I was going to have. I initially wanted to be a history teacher out of high school, so I had no idea what I actually wanted to do. and just getting into this and, finding the love for it and just constantly trying to get to, the grindstone to sharpen your skills. It's always that grind to just keep doing better, and that's always rewarding. And then when you get to a certain point and you start inspiring people or they're reaching out to you, it's like, oh wow, you're reaching out to me, to be at that, getting to that level where you can now help other